Our home galaxy hides secrets stranger than fiction. We are about to embark on a journey to 25 of the Milky Way's most bizarre and enigmatic objects, a tour that will fundamentally change how you see the night sky. You will discover a star made of diamond, a region of space so empty it defies logic, and a cosmic geyser erupting from the galaxy's heart. How could a star possibly be older than the universe itself? And what is the true nature of the dark matter galaxy that is almost entirely invisible? The cosmos is not just beautiful, it is profoundly weird. What single cosmic mystery do you find the most compelling? Our journey begins not with a star, but with a violent, invisible beacon of pure destruction. Deep within the crowded core of the Milky Way, roughly 10,000 light-years from Earth, lies a peculiar object known to astronomers as the Great Annihilator. Its name is not an exaggeration. This cosmic entity is one of the brightest sources of gamma rays in our entire sky, and it produces this terrifying energy through a process as fundamental as it is violent, the annihilation of matter and antimatter. To understand the strangeness of this object, we must first grasp a simple, profound truth. For every particle of matter that makes up our world, our bodies, the planets and the stars, there exists an equal and opposite particle of antimatter. They are perfect mirror images, identical in mass but opposite in charge. And when matter and antimatter meet, they do not simply collide. They annihilate each other in a flash of pure energy, vanishing completely and releasing a burst of gamma rays, the most powerful form of light in the universe. This is the power source of the Great Annihilator. It is somehow producing and destroying antimatter on a colossal scale. The leading theory suggests it is likely a binary system, a dance between a small, dense stellar corpse like a neutron star or a black hole and a normal companion star. As material is ripped from the normal star, it spirals into an incredibly hot, spinning disk around its dense partner. In the furnace-like conditions of this disk, conditions are so extreme that particle pairs, matter and antimatter, are spontaneously created from raw energy. These newly born particles are then almost immediately forced together, annihilating in a continuous, brilliant firestorm of gamma rays that we can detect from across the galaxy. Yet the true mystery remains. The sheer intensity and specific energy of the gamma rays we see do not perfectly match our models. Something about the environment, the magnetic fields, or the very nature of the dense object at the heart of this system is creating antimatter in a way we do not fully understand. It is a natural laboratory for the most extreme physics, a place where the basic rules of our universe are written in light 1,000,000 times more energetic than visible light. To stand in its presence, if such a thing were possible, would be to witness the fundamental building blocks of reality being unmade before your eyes. But if the Great Annihilator represents a point of terrifying, concentrated energy, our next object is its polar opposite. It is a staggering absence, a cosmic desert so vast and so empty it seems to defy the very nature of the universe. This is the Boötes Void, a region of space often called the Great Nothing. To understand its scale, you must first picture our cosmic neighborhood. Galaxies are not scattered randomly like stars in the night sky. They are arranged in an immense web-like structure. Great walls and filaments of galaxies surround vast, bubble-like voids. The Boötes Void is one of these bubbles, but it is not typical. It is a supervoid, a colossal spherical region of space roughly 250 million light-years across. If you placed our Milky Way at the center of this void, the night sky would be almost pitch black. The nearest major galaxy would be so far away it would be a faint, lonely speck. The sheer emptiness is difficult to comprehend. A sphere 250 million light-years in diameter contains a volume of space so immense it could hold tens of thousands of galaxies like our own. Yet, astronomers have only found about 60 galaxies within it. That is not just sparse, it is profoundly, unnaturally empty. According to our best models of how the universe evolved after the Big Bang, matter should have clumped together more evenly. A void this size should not exist, or at least it should contain far more galaxies than it does. Its discovery was a shock that forced cosmologists to rethink their understanding of cosmic structure. How could such a nothingness form? One theory suggests it might be the result of smaller voids merging over billions of years, like soap bubbles combining into one gigantic bubble. Another, more speculative idea is that it could be evidence of something even stranger at work in the early universe, a flaw in the fabric of space-time itself. The Boötes void is not a vacuum. It still contains the thin gas between galaxies and the mysterious dark matter that binds the cosmos, but its lack of luminous matter of stars and galaxies makes it a haunting landmark. It is a reminder that the universe is not just clumps of matter, but is defined equally by its emptiness. It challenges us to explain not just what is there, but what is conspicuously, overwhelmingly not. While the Boötes void presents a chilling emptiness, our next object is a scene of horrifying intimacy. It is a cosmic predator, a spinning corpse of a star that is methodically destroying its partner. This is the Black Widow pulsar, a celestial object that lives up to its terrifying namesake. A pulsar is the ultra-dense, rapidly spinning core left behind after a massive star explodes in a supernova. This particular pulsar, officially known as PSRB 1957+20, spins at an almost incomprehensible rate, completing over 600 rotations every single second. That means a city-sized ball of pure neutron star material, heavier than our Sun, is whirling so fast its surface moves at a significant fraction of the speed of light. This furious spin powers intense beams of radiation that sweep across space like a lighthouse. But this pulsar is not alone. It is locked in a tight, lethal orbit with a small, lightweight companion star, likely a brown dwarf. They are so close that their orbital dance takes only about 9 hours. This proximity is the companion's death sentence. The pulsar's powerful radiation and relentless particle winds are bombarding the facing side of this smaller star, literally cooking and vaporizing it. The energy is so intense it strips material away, creating a swirling cloud of superheated plasma that slowly erodes the companion. Astronomers call this process ablation. Picture a block of ice held inches from a blowtorch melting and steaming away. The companion star is suffering a similar cosmic fate. This slow-motion destruction teaches us a brutal lesson about binary star system evolution. We are witnessing the final stages of a stellar relationship that began billions of years ago with two normal stars. The more massive one exploded, leaving behind this pulsar. Now, the remnant is consuming the other. Over millions of years, the pulsar will completely evaporate its partner, leaving behind a solitary, spinning beacon. The Black Widow pulsar shows us that even in death, a star can become a vampire, surviving by draining the life from its celestial neighbor. From a scene of stellar cannibalism, we turn to a structure of breathtaking and unnatural geometry. Suspended in the darkness, roughly 2,300 light-years away in the constellation Monoceros, is an object that looks less like a cosmic cloud and more like a carefully drafted technical drawing. This is the Red Rectangle Nebula, a glowing X-shaped structure with a series of concentric, ladder-like rungs connecting its arms, all enveloped in a faint red rectangular haze. Its precise symmetry is utterly alien in a universe dominated by swirling spirals and chaotic clouds. Such perfect geometry does not arise by chance. It requires a precise and ongoing engine. That engine is a pair of dying stars at the nebula's heart. This central binary system consists of an aging red giant star and a smaller, hotter companion. As the red giant nears the end of its life, it puffs away its outer layers in a slow, steady stellar wind. Normally, this would create a spherical shell of gas, a classic planetary nebula. But here, the companion star's gravity and the powerful orbital dance between the two stars' shape that outflow into two opposing cones of material. From our vantage point on Earth, we are looking directly down the barrel of one of these cones, seeing the edges of the cone walls as the vivid X shape. The mysterious ladder rungs are thought to be periodic outbursts from the stars, ejecting rings of material at regular intervals that expand outward, creating the illusion of steps on a cosmic staircase. Yet the geometry is only half the mystery. The nebula's intense red glow comes from a phenomenon known as extended red emission, a broad band of light we do not fully understand. More perplexing are the strong, unidentified infrared bands detected within its dust. These are specific signatures or fingerprints in the infrared spectrum that correspond to no known chemical on Earth. For decades, they have defied explanation. The leading hypothesis points to complex organic molecules, perhaps built around chains of carbon atoms, something akin to large molecules of soot or even the basic building blocks of future life. The red rectangle, then, is more than a beautiful oddity. It is a cosmic factory, a controlled laboratory where the death throes of stars are sculpted by gravity into precise forms, and where those very same processes may be forging the complex chemistry that could one day seed new worlds. It is a reminder that order can emerge from stellar chaos, and that within the funeral shroud of a star, the ingredients for new beginnings might already be stirring. The red rectangle's precise geometry hints at hidden order, but at the very heart of our galaxy, we find objects whose behavior seems to defy the most fundamental laws of physics. Orbiting perilously close to the supermassive black hole known as Sagittarius, a star, are entities that should not exist. Astronomers call them the G objects. From a distance, they look like harmless, puffy clouds of gas, several times wider than our entire solar system. They follow elongated, comet-like orbits that bring them screaming to within just a few hundred times the Earth-Sun distance from the black hole's event horizon. At that proximity, the tidal forces are unimaginable. The pull of gravity on the side of an object facing the black hole is exponentially stronger than the pull on its far side. Any normal cloud of gas and dust should be instantly shredded, stretched into a long, thin streamer and swallowed, like a droplet of ink falling into a vortex. Yet the G objects are not shredded. They approach the point of no return, swing around the black hole at a significant fraction of the speed of light, and then travel back out on their long orbits, seemingly intact. This is the central mystery. How can a fragile cloud of gas survive a close encounter with the most destructive environment in the galaxy? The answer may be that these are not mere clouds at all. The leading theory is far more bizarre. Each G object might be a concealed star, cloaked in a thick, extended shroud of gas and dust. Imagine a normal star, but one that has grown so bloated and puffy after colliding with another star that it has become obscured, hidden within a gigantic, opaque envelope. This dense cloak would explain why they appear as clouds in our telescopes. The star at the core provides the gravitational glue, the internal structure, that holds the entire object together against the black hole's ferocious tides. It is a cosmic trick, a stellar matryoshka doll where the true nature is hidden inside a deceptive outer shell. Their survival teaches us something profound about the chaotic environment at the galactic center. The fact that these objects exist at all suggests that stellar collisions and mergers must be common in that crowded, violent neighborhood, creating these strange hybrid bodies. With every perilous orbit, the black hole's gravity slowly strips away their outer layers, meaning we are watching a slow unraveling, a cosmic striptease that may eventually reveal the naked star within. The G objects are more than just curiosities. They are extreme physics probes testing the limits of stellar endurance and giving us a unique way to map the invisible gravitational landscape right at the edge of our galaxy's central abyss. The galactic center is a place of violent extremes, but the deepest mysteries sometimes arrive as a whisper from the quiet dark. In the summer of 1977, a radio telescope in Delaware, Ohio, part of the Search for Extraterrestrial Intelligence project, recorded a signal so powerful and so peculiar that the astronomer reviewing the data, Jerry Amon, simply circled it on the printout and wrote one word in the margin. Wow, this single event, lasting 72 seconds, remains the most compelling candidate for a signal of intelligent extraterrestrial origin ever detected. It was not random noise or a known natural phenomenon. It was a narrowband radio burst precisely at the frequency of neutral hydrogen, the most common element in the universe and a logical channel for any civilization trying to announce its presence. The signal came from a specific point in the constellation Sagittarius, not far from the galactic center, and then it vanished, never to be heard again. This region of space, now known as the WOW signal source region, has become a hallowed ground for SETI scientists. It is not a physical object you can see, but a celestial address, a point on the map where something extraordinary may have happened. The profound frustration and enduring hope of the search stems from that single, unrepeated event. Imagine hearing a clear, strong voice call your name once from a crowded room and then only silence. Was it a greeting, a malfunctioning beacon, a cosmic accident? For decades, telescopes have been pointed back at that spot, listening intently for a follow-up, for any hint of a repeat transmission. They have scanned not just that exact frequency, but millions of frequencies around it. They have looked for patterns, for slower pulses, for anything that might confirm an intelligent source. So far, the silence has been absolute. This ongoing search highlights the immense challenge of SETI. The WOW signal was detected by a telescope that could only observe one point in the sky at a time. The universe is vast, and a transmission could be brief, directed, or intermittent. It is like trying to catch a specific lightning bug in a continent-sized forest with a flashlight that only illuminates one tree at a time. The implications of a confirmed signal are universe-altering, but the lack of a repeat forces us to confront other possibilities. Could it have been a natural astrophysical event we still do not understand? Perhaps a comet's hydrogen cloud or a novel form of stellar flare? Or was it indeed a message, a one-time broadcast from a civilization that has long since gone silent? The WOW signal source region stands as a monument to a fundamental human question, asked not to the sky but by it. It is a reminder that the search for other minds in the cosmos is a game of patience played across unimaginable distances and timescales, where a single, unexplained event can echo for generations. The silent question of the WOW signal speaks to a universe that might be full of minds, but our next discovery proves it is also full of impossible treasures. Orbiting a dead star 2,500 light-years away is a world that defies every expectation of what a planet can be. Known as PSRJ 1719-1438b, this is an object so dense and so bizarre that astronomers are confident it is, for all intents and purposes, a planet-sized diamond. Its story begins with a catastrophic transformation. Billions of years ago, this system was likely a binary pair, two stars orbiting one another. The more massive of the two burned through its fuel quickly and died in a supernova, leaving behind an ultra-dense, rapidly spinning stellar corpse called a millisecond pulsar. This remnant, now a city-sized ball of pure neutrons, began a vampiric process. Its intense gravity started siphoning material away from its surviving companion star. Over eons, this stellar theft stripped the companion down to its bare, dying core. What remained was not enough to sustain nuclear fusion. The companion was utterly consumed, leaving behind only its heart, an object with the mass of Jupiter but compressed into a sphere only about 5 times the size of Earth. This is the diamond planet. The incredible pressure from this compression is the key to its nature. The core of that devoured star was rich in carbon and oxygen. Under the immense gravitational crush of its own mass, and subjected to the relentless radiation from its pulsar master, those elements were forced into an extreme state. The carbon atoms, instead of forming graphite or soot, were squeezed into the rigid crystalline structure of diamond. Imagine taking a star's heart, applying pressure greater than anything in our solar system, and forging it into a single gargantuan gem. This world is not a glittering sphere in the sense of a cut jewel in a museum. It is a dark, incredibly dense crystalline mass, likely with a surface of graphite over a mantle of diamond hundreds of miles thick. There would be no atmosphere, no liquid water, no light but the piercing beam of its pulsar sun sweeping across the sky every few hours. It is a monument to stellar cannibalism and alchemy, a tombstone for a star that was transformed into the universe's most precious relic. This diamond planet challenges our very definition of a planet. It is the remnant core of a star, yet it orbits another stellar remnant. It is a world, but one forged in a furnace of destruction and compression that makes the geology of our own rocky Earth seem gentle by comparison. It stands as a breathtaking example of cosmic recycling, where the death of one star creates a treasure of almost mythical proportions from the ashes of another. The diamond planet is a treasure forged from stellar ruin, but some cosmic survivors are not just relics, they are predators frozen in time. Tucked away in the constellation Perseus, a staggering 220 million light-years from Earth, lies a galactic fossil known as NGC 1277. This massive elliptical galaxy appears to be a cosmic cannibal, a relic from the universe's violent youth that has remained essentially unchanged for over 10 billion years. While most galaxies, including our Milky Way, are dynamic workshops continuously forming new generations of stars from swirling clouds of gas, NGC 1277 is a silent red graveyard. Its star formation ceased an eternity ago, and the galaxy is now dominated by an ancient population of old red stars. This alone makes it a fascinating time capsule, but its true strangeness lies in its proportions and its history. Despite its large mass, this galaxy is incredibly compact, packing its stars into a volume much smaller than modern galaxies of similar heft. The most startling discovery, however, concerns its core. Measurements of how stars move near its center suggest the presence of a supermassive black hole of absolutely monstrous size, one that could account for a staggering portion of the galaxy's entire mass. This is wildly out of sync with what we see in galaxies today, where central black holes typically make up only a tiny fraction of a galaxy's total bulk. So, what happened here? Astronomers believe NGC 1277 is a relic galaxy, a survivor from the first few billion years after the Big Bang, when the universe was a far more chaotic and crowded place. In that dense, primordial environment, galaxies formed quickly and furiously. NGC 1277 likely gorged itself early on, consuming vast amounts of gas and perhaps even smaller neighbor galaxies in a series of violent mergers. This feeding frenzy would have triggered an intense, brief burst of star formation that used up all the available fuel. Then something stopped. Perhaps it was ejected into a lonely orbit within its galaxy cluster, cutting it off from fresh supplies of intergalactic gas. Or maybe the sheer energy output from its colossal black hole and those early stellar explosions blew away any remaining star-making material. The result is a galaxy in stasis. It is a snapshot of the early universe's most massive and voracious galaxies, a cosmic dinosaur that never evolved into the more settled spiral or elliptical forms we see around us today. Its sea of ancient red stars tells a story of a dramatic beginning and a very long, quiet retirement. Studying this cannibal relic is like finding a perfectly preserved artifact from a lost civilization. It gives us direct evidence of how the universe's first giant galaxies built themselves through relentless consumption, and then simply stopped, becoming the silent, red sentinels we observe across the deep reaches of cosmic time. Zeta Ophiuchi is a star on the run, a brilliant blue giant over 20 times more massive than our Sun. It is not drifting peacefully through its corner of the galaxy. It is fleeing, plowing through the depths of interstellar space at a breathtaking speed of 160,000 kilometers per hour. At this velocity, you could travel from Earth to the Moon in about 90 minutes. This is no ordinary stellar motion. This is a celestial cannonball. Its passage creates one of the most spectacular sights in the Milky Way, a colossal bow shock wave that glows in vivid infrared light. Picture the wave that forms at the prow of a speeding boat, a curved wall of water pushed ahead of it. Zeta Ophiuchi creates the cosmic equivalent, but on a scale that dwarfs our entire solar system. As the star hurtles through a region of thinner gas and dust, its powerful stellar wind, a constant stream of charged particles, slams into the stationary interstellar medium. This collision compresses and heats the material, sculpting it into a glowing, crescent-shaped wall that stretches over 4 light-years across. The star itself is not at the center of this arc. It is off to one side, like a runner who has already passed through the finish line tape they are still stretching out behind them. This dramatic scene begs a critical question. What kind of cosmic event could possibly give a star this massive such a tremendous kick? Stars of this size do not simply get up and sprint. The leading theory is as violent as it is fitting, a gravitational slingshot from a supernova explosion. Astronomers believe Zeta Ophiuchi was not born alone. It was likely once part of a tight binary system, orbiting an even more massive partner. That partner, living fast and dying young, eventually exhausted its nuclear fuel and collapsed, triggering a titanic supernova blast. The explosion would have been asymmetrical, literally blowing the binary system apart. In an instant, the companion star was utterly annihilated. Zeta Ophiuchi, suddenly freed from its gravitational tether and given a ferocious kick by the explosive force, was flung into the void like a stone from a catapult. We are now seeing it centuries later, still carrying the momentum from that ancient detonation. It is a runaway, a survivor fleeing the scene of its partner's catastrophic death. Its lonely, high-speed journey through space will eventually end, as all massive stars do, in its own supernova explosion. But for now, it travels alone, its brilliant light and the magnificent shock wave ahead of it serving as a permanent wake, a testament to the explosive power that set it adrift among the stars. The violent flight of Zeta Ophiuchi shows how stars can be scarred by their past, but some stellar behavior points to a present we cannot yet explain. Among the hundreds of thousands of stars monitored by the Kepler Space Telescope, one stood out as profoundly and persistently strange. Known as KIC 8462852, or Boyajian star, it exhibits a pattern of dimming unlike anything else in the cosmos. Most planets cause predictable, periodic dips in a star's light as they transit, like a steady, rhythmic blink. Boyajian star does nothing of the sort. Its light curves are chaotic. It experiences sudden, dramatic drops in brightness by as much as 22%, far too much for even a Jupiter-sized planet to cause. These dips are irregular in timing, duration, and depth. Sometimes the star dims for days, other times for weeks. The pattern is not a clean, repeating signal. It is a messy, unpredictable stutter. The initial discovery sparked a frenzy of speculation, with the most tantalizing hypothesis being that of an alien megastructure. The idea was that a vast, incomplete swarm of solar collectors, known as a Dyson swarm, could be orbiting the star, constructed by an advanced civilization to harness its energy. These collectors would block the starlight in irregular, jagged patterns, just as we observed. It was a hypothesis born from pure scientific deduction, a last resort after all known natural explanations seemed to fall short. Other, more conventional theories were proposed. Perhaps a giant, fragmented comet or a massive swarm of cometary debris was orbiting the star in a tight, chaotic cloud, periodically blocking its light. Maybe the star had recently consumed a planet, creating a temporary disk of shattered debris. Or perhaps the dimming was caused by something intrinsic to the star itself, a kind of stellar tantrum we had never witnessed before. Years of intense follow-up observations have slowly peeled back the layers of this mystery. The alien megastructure hypothesis, while captivating, has lost significant ground. Detailed analysis of the star's light across different wavelengths revealed a crucial clue. When the star dims, it dims more in some colors of light than in others. This is a telltale signature of starlight passing through dust. A solid megastructure, like a giant metal panel, would block all colors of light equally. Dust, however, scatters blue light more effectively than red light. The observed pattern strongly suggests the dimming is caused by clouds of fine, microscopic dust particles passing in front of the star. The current scientific consensus points toward a complex, evolving cloud of dust as the primary culprit. This dust is likely the debris from a catastrophic collision or disintegration event, perhaps a moon-sized body breaking apart or a family of comets being gravitationally shredded. The irregular dips could be caused by dense clumps within this debris field, with the finer dust creating a long-term, gradual dimming trend also observed at the star. So, while the dream of a discovered megastructure fades, the reality is no less fascinating. Boyajian's star presents us with a natural laboratory for planetary system destruction and chaos. We are witnessing the aftermath of a cosmic disaster, a real-time display of how celestial bodies can tear themselves apart, creating a veil of dust so vast and intricate it can make a star flicker like a faulty bulb from over 1,000 light-years away. The mystery has evolved from a question of who to a question of what cataclysm could produce such an enduring, intricate shadow. While Boyajian's star flickers with the shadows of dusty debris, there is another stellar monster whose instability lights up the entire southern sky. Eta Carinae is not just a star, it is a cosmic catastrophe in slow motion, a luminous blue variable hypergiant that holds the title of the most massive and unstable star system we can study in detail. Residing about 7,500 light-years away in the Carina Nebula, this behemoth is actually a binary system, with the primary star containing the mass of at least 100 suns and shining with the power of 5 million. It is a star so colossal and so violently energetic that it barely holds itself together, constantly threatening to tear apart under its own radiant pressure. Its defining moment in recorded human history arrived in the 1840s, during an event astronomers call the Great Eruption. For over a decade, Eta Carinae became the second brightest star in the entire night sky, outshone only by Sirius despite being hundreds of times farther away. It was a stellar outburst of incomprehensible scale, not a supernova, but something almost as violent. The star did not destroy itself. Instead, it violently ejected an enormous amount of its own outer layers, enough material to make 10 of our suns. This titanic explosion did not blast the material evenly into space. It was funneled by the star's rotation and the influence of its companion, sculpting the ejector into a distinct hourglass shape. We now see this expelled material as the Homunculus Nebula, a vast bipolar cloud of gas and dust that continues to expand outward at millions of kilometers per hour. In telescope images, it looks like a glowing cosmic butterfly or a pair of opposing lobes, with the brilliant, unstable star system blazing at its waist. The homunculus is more than just a remnant, it is a time capsule. The gas and dust from that eruption are racing outward, and by studying their motion and composition, we can effectively rewind the tape, reconstructing the precise conditions of that 19th century detonation. This makes Eta Carinae a unique laboratory for understanding the final, frantic years of the most massive stars. Today, the star remains wildly unpredictable, its brightness fluctuating dramatically as it struggles against its own gravity. It is surrounded by a complex nest of older debris from previous outbursts, evidence of a long history of violent instability. All of this points toward one inevitable conclusion. Eta Carinae is a prime supernova candidate, a ticking time bomb on a cosmic scale. when it finally does go supernova, and astronomers believe it could happen at any moment within the next several 100,000 years, perhaps even sooner, the event will be spectacular. For a brief period, it could become as bright as the full moon, visible even in broad daylight. The explosion will flood our region of the galaxy with high-energy radiation and cosmic rays, and the remnant it leaves behind will likely be a black hole, a permanent mark where one of the galaxy's most brilliant and troubled giants once lived. We are watching a prelude to one of the universe's most energetic events, a front-row seat to a star writing its own violent epitaph in light and gas. The violent instability of stars like Eta Carinae is a local spectacle, but a far grander and more mysterious eruption has left its mark on the entire galaxy. Stretching from the galactic core, two colossal bubbles of searing energy tower above and below the plane of the Milky Way. These are the Fermi bubbles, named for the space telescope that discovered them in 2010. Each one is a monstrous structure, a lobe of hot gas and high-energy radiation reaching 25,000 light-years into intergalactic space. To grasp their scale, if you could see them in the night sky, they would span over half of it, an immense hourglass of invisible energy centered on the constellation Sagittarius. They are not made of stars or dust, but of something far more energetic: gamma rays and X-rays, the signature of particles moving at nearly the speed of light. This discovery was a complete surprise, revealing that our galaxy's recent history was far more explosive than anyone had imagined. The bubbles are essentially a pair of giant, ongoing explosions, a titanic geyser of energy that has been blowing outward from the galactic center for millions of years. But what cosmic engine could possibly produce such a vast, symmetrical structure? The debate centers on two cataclysmic possibilities, both tied to the violent environment at the heart of the Milky Way. The first and perhaps most dramatic theory points directly to the supermassive black hole, Sagittarius, a star. While it is quiet today, it may have had an active and violent past. Millions of years ago, a massive cloud of gas or even a star could have wandered too close and been torn apart. As that material spiraled into the black hole's accretion disk, it would have heated to unimaginable temperatures, releasing a torrent of radiation. But not all that infalling matter would have been swallowed. Some of it, channeled by powerful magnetic fields, could have been shot back out into space in two opposing jets, perpendicular to the galactic disk. These jets, plowing into the thinner gas of the galactic halo, would have inflated these gigantic, bubble-like structures we see today. It would have been a brief but spectacular eruption, a black hole belch on a galactic scale. The second major theory looks not to the black hole, but to a frenzy of stellar birth and death. The galactic center is a crowded, chaotic place where gas clouds can collapse to form stars at a ferocious rate. This could have triggered a starburst event, a period where thousands of massive stars were born in a relatively short time. These stars live fast and die young, exploding as supernovae in quick succession. The combined shockwaves from hundreds or thousands of these explosions, all concentrated in the core, could have blown a gigantic, clean bubble outwards in both directions, much like a strong wind blowing bubbles from a child's wand. The energy required is staggering, but the dense star-forming regions at the galactic center could have provided it. So which is it, a black hole outburst or a starburst? The evidence is still being gathered. The sharp, defined edges of the bubbles and the specific spectrum of gamma ray light they emit provide clues. Some observations suggest the bubble's features are better explained by a single, powerful event from the black hole, while others point to a more sustained energy input from stellar winds and supernova. It is possible both mechanisms work together, a feedback loop where star formation fueled activity around the black hole. The Fermi bubbles are a ghostly monument to a cataclysm we missed by millions of years, a reminder that our seemingly placid galaxy has a violent temper and that its calm spiral disk is crowned by a pair of scars from an eruption that once lit up the local universe. The cataclysmic energy of the Fermi bubbles reminds us our galaxy has a violent history, yet the greatest cosmic challenge might not come from an explosion, but from a single, quiet point of light. In the constellation Libra, a mere 190 light-years away, shines a star that for years threatened to unravel our entire understanding of cosmic history. This is the Methuselah star, officially catalogued as HD 140283. It is a subgiant, a star in the late stages of its life, and it is composed almost entirely of hydrogen and helium with only trace amounts of heavier elements. That pure composition marks it as a second-generation star, one of the very first to form after the Big Bang. Its pristine nature makes it a perfect cosmic clock. By measuring its brightness, temperature, and composition with extraordinary precision, astronomers can estimate its age with a high degree of confidence. The initial calculations using data from the Hubble Space Telescope delivered a staggering and impossible result. The Methuselah star appeared to be about 14.5 billion years old. The problem, the best estimate for the age of the universe itself, derived from the cosmic microwave background radiation, is 13.8 billion years. This created a profound paradox. How could a star be older than the cosmos that birthed it? It was as if you found a birth certificate for a person who was born a full decade before their parents met. The discrepancy sent shockwaves through cosmology, forcing scientists to re-examine everything from their stellar models to their fundamental picture of the universe's expansion. The resolution did not come from discarding the star's age, but from refining our measurements with even greater care. Astronomers realized that the star's exact distance was a critical and slightly uncertain variable in the age calculation. A tiny adjustment in that distance could significantly alter the age estimate. New, ultra-precise parallax measurements from the Gaia Space Observatory provided a more accurate fix on the star's position. When this updated distance was plugged into the sophisticated stellar evolution models, along with a better accounting of the star's oxygen content, the estimated age shifted. The Methuselah star is now pegged at approximately 14.27 billion years, give or take about 800 million years. This revised age, while still brushing up against the universe's 13.8 billion year age, is no longer a direct contradiction. The margin of error now allows the star to be younger than the cosmos. The paradox was averted not by a revolutionary new theory, but by the painstaking work of reducing uncertainty. This star remains one of the oldest known objects in the entire galaxy, a living relic from the universe's infancy. Its light carries the signature of a time before planets, before most heavy elements, when the cosmos was a simpler, darker place. It is a touchstone to our deepest past, a reminder that our maps of cosmic history are always being redrawn, not by discarding old stars, but by learning to read them with ever more clarity. While the Methuselah star anchors us to the dawn of time, our next discovery is a ghost, a galaxy defined not by what we see, but by what we cannot. Drifting in the Coma cluster, 300 million light-years away, is Dragonfly 44, an object that has rewritten the definition of a galaxy. At first glance, it is almost nothing. Through a telescope, it appears as a faint, wispy smudge of light, an ultra-diffuse galaxy with a fraction of the stars found in our Milky Way. You could see right through it, yet this faint puff of starlight holds a terrifying secret. When astronomers measured the motions of its sparse stars, they found them whizzing around at astonishing speeds. According to the laws of gravity, those stars should be flying apart, scattering into the void, unless something was holding them together. That something is an immense, invisible mass. The calculated weight of Dragonfly 44 is staggering, nearly equal to the mass of our own star-rich Milky Way. But where our galaxy shines with hundreds of billions of stars, Dragonfly 44 has only about 1% of that. Where is all that missing mass? The inescapable conclusion is that this galaxy is made almost entirely of dark matter. To be precise, a staggering 99.99% of its substance is the mysterious, invisible glue that binds the cosmos, with a mere whisper of familiar stars floating within it like dust motes in an empty cathedral. This discovery was a profound shock. It presented us with a galaxy that is essentially a pure dark matter halo, a cosmic skeleton with almost no luminous flesh. For decades, dark matter has been a theoretical necessity, an unseen force we infer because galaxies rotate too fast and galaxy clusters hold together too tightly. But here was Dragonfly 44, a laboratory where the dark matter vastly outweighs everything else, making its gravitational signature unmistakable. It is the ultimate dark matter experiment happening naturally in deep space. The existence of such an object challenges our models of how galaxies form. How could a halo of dark matter accumulate so much mass while gathering so few stars? One possibility is that it was once a more normal galaxy, but its gas was stripped away by the fierce gravitational tides of the crowded Coma cluster, halting star formation and leaving behind this dark matter fossil. Another, more intriguing idea is that it formed this way from the beginning, a dark matter cloud that simply never managed to attract enough ordinary gas to light up. Dragonfly 44 forces us to ask if dark matter itself has a richer structure than we thought. If there are entire galaxies, even clusters, made predominantly of this shadow substance, invisible to our telescopes but shaping the cosmos through gravity alone. It is a haunting reminder that what we see in the night sky is only a decorative glitter on the surface of a much darker, much heavier reality. Dragonfly 44 reveals a cosmos dominated by invisible mass, but our next discovery proves that even the most familiar objects can hide a startling, rhythmic secret. Among the sea of stars monitored by the Kepler Space Telescope, astronomers began noticing a peculiar and persistent signal. Some stars were not just dimming from planetary transits or flickering from internal turmoil. They were pulsing with a steady, rhythmic brightening like a cosmic heartbeat. These are the so-called heartbeat stars, a class of eccentric binary systems that wear their intimate gravitational dance on their sleeves, or rather, in their light. Each pair consists of two stars locked in a highly elliptical, oval-shaped orbit, not a perfect circle. For most of their long orbital period, which can range from days to weeks, they are distant, serene companions. But when they swing close together at their point of closest approach, something extraordinary happens. The immense gravitational pull of each star literally stretches the other. They are not solid spheres but giant balls of superheated plasma, and as they near each other, their mutual gravity pulls them into egg-shaped or teardrop forms. This dramatic tidal distortion changes the amount of surface area facing us, and because a star's brightness is directly tied to the amount of surface we can see, this stretching causes a sharp, predictable spike in their combined light. The light curve, the graph of their brightness over time, looks nothing like the flat line of a quiet star or the clean dip of a planet transit. Instead, it shows a steady baseline punctuated by a steep, symmetrical peak at each close encounter, followed by a series of smaller harmonic oscillations that slowly fade like the ringing of a bell. That is the true magic of these systems. The initial tidal spike is just the first note. The stars do not simply snap back into a perfect sphere, they oscillate, ringing with internal vibrations. By studying the frequency and decay of these harmonic oscillations, astrophysicists can perform a kind of cosmic ultrasound. They can probe the internal structure of the stars, measuring their density, composition, and how material moves within them in ways that are impossible for a solitary star. It is stellar seismology on a grand gravitational scale. These systems are more than just celestial curiosities, they are precision laboratories. Because the timing and shape of the heartbeat are exquisitely sensitive to the stars' masses and orbits, astronomers can measure these properties with incredible accuracy. They can even detect the subtle effects of general relativity, like the slow precession of the orbit, in real time. Each rhythmic pulse is a direct transmission of the fundamental forces shaping the system, a conversation between gravity and starlight written across light years. The existence of such perfectly synchronized eccentric pairs also tells a story of cosmic history. How did they end up in such a stretched-out orbit without merging or circularizing? Their survival suggests a gentle, almost poetic past, perhaps influenced by a third star that has since departed, leaving behind this delicate, oscillating duet. In the silent vacuum of space, these stars are not silent at all. They thrum with the energy of their mutual embrace, sending out a regular, luminous pulse that turns the abstract force of gravity into a visible, measurable rhythm for anyone with the patience to listen. The rhythmic heartbeat of binary stars speaks to a cosmos of predictable interactions, but deep in the crowded stellar nurseries of the galactic center, astronomers have just discovered a class of ancient stars with a strange, smoky temper. They are called the Old Smokers, and they represent a previously unknown and critically important phase of stellar life. These are not brilliant blue giants or violent pulsars, but elderly red giant stars quietly lurking in the dense, dusty heart of the Milky Way. For decades, they went unnoticed, blending into the background clutter. But recent, long-term infrared surveys finally caught them in the act of a bizarre transformation. An old smoker will sit quietly for years, even decades, emitting a steady, dull glow. Then, without obvious warning, it will begin to dim dramatically, its visible light fading by as much as 97%, becoming almost invisible. At the same time, its infrared signature, the heat it radiates, skyrockets. This is the telltale sign of a star suddenly shrouding itself in a thick, opaque cloud of freshly ejected dust. Imagine a gentle campfire that, for no apparent reason, suddenly billows out an immense cloud of black smoke, hiding its flames and radiating heat. That is precisely what these stars are doing on a cosmic scale. They are not exploding, they are belching. The leading theory is that these eruptions are tied to the final, unstable stages of a star's life. As a sun-like star nears the end of its hydrogen fuel, it swells into a red giant. In its deep, convective outer layers, conditions might become just right for dust grains, tiny particles rich in elements like carbon, silicon, and oxygen, to condense out of the stellar atmosphere like soot in a chimney. If enough of this dust forms close to the star, it can create a shroud so thick it blocks the star's own light. The radiation pressure from the star then pushes this vast cloud of newly forged elements out into space, after which the star clears and brightens again, only to repeat the process centuries or millennia later. This discovery is revolutionary because it suggests a new, gentle mechanism for dispersing heavy elements. We knew that supernova and stellar winds scatter the building blocks of planets and life, but the old smokers offer a slower, more patient delivery service. Each smoky eruption seeds the surrounding interstellar clouds with complex dust, the very raw materials for future stars, planets, and perhaps even living organisms. These ancient, coughing giants may be the galaxy's quiet gardeners, patiently fertilizing the stellar nurseries around them with the essential ingredients for new cosmic beginnings. A stellar nursery is supposed to be a place of birth, but the oldest star clusters in our galaxy have become graveyards. Within these ancient globular clusters, balls of hundreds of thousands of stars that date back to the Milky Way's infancy, every sun should be aging in unison. They all formed from the same primordial gas cloud over 10 billion years ago. Logic dictates they should all be in the same late, cool stage of life, a uniform sea of red and yellow elderly stars. Yet, when astronomers point their telescopes at these cosmic retirement homes, they spot defiant outliers. Scattered among the ancient red giants are brilliant, hot blue stars. They burn with the fierce energy of youth, appearing millions, even billions, of years younger than their neighbors. These cosmic anomalies are known as blue stragglers, and their very existence in such an environment is a glaring violation of stellar demographics. How can a star be young in a place where star formation ended eons ago? The answer is not that these stars were born late, but that they were reborn. They are stellar phoenixes created through violence and intimacy. The leading theory to explain their youthful blue glow points to a dramatic stellar collision. In the dense core of a globular cluster, stars are packed incredibly tightly. The distance between them can be 100 times closer than in our own galactic neighborhood. In this celestial traffic jam, close encounters and direct crashes, while still rare on human timescales, become inevitable over billions of years. When two older, sun-like stars collide, their cores merge. The resulting single star inherits the combined hydrogen fuel of both its progenitors. With this fresh supply of fuel, and now with a greater mass, it reignites nuclear fusion with a new ferocity. It puffs itself up, heats its surface, and shines with the blue-white light of a much younger, more massive star. It is not a newborn, but a recycled veteran given a second, hotter life. Another compelling path to creating a blue straggler is less about a sudden crash and more about a slow, gravitational embrace. Many stars in the universe are born in binary pairs. In a globular cluster, the gravitational pull of a passing star can tighten the orbit of such a binary system, drawing the two stars closer together over time. As they spiral inward, the larger star begins to siphon material, hydrogen fuel, from its companion. This stellar vampirism transfers fresh fuel to the more massive star, rejuvenating it and increasing its mass, causing it to blaze hotter and bluer. In some cases, the transfer is so complete that the two stars may eventually merge entirely, creating a single, more massive and hotter blue straggler. These stars are cosmic imposters, wearing the vibrant colors of youth stolen from their neighbors or forged in collisions. Their discovery forced astronomers to realize that stellar evolution is not always a solitary, predictable journey. In the crowded dance halls of globular clusters, stars can exchange partners, merge, and be fundamentally reborn. The blue stragglers are living proof that even in the oldest corners of our galaxy, drama and renewal are always possible, written in the brilliant, defiant blue light of a star that refused to grow old gracefully. The blue straggler's stolen youth is a quiet drama, but some stellar corpses announce their presence with the force of a cosmic sledgehammer. Deep in the constellation Vulpecula, roughly 30,000 light-years away, a dead star is rewriting the rules of stellar magnetism. This is SGR 1935 plus 2154, a special class of neutron star known as a magnetar. To grasp its power, you must first understand the extreme nature of its birth. When a massive star dies in a supernova, its core collapses. If that core is between about 1.4 and 3 times the mass of our Sun, it crushes down into a neutron star, a city-sized ball of matter so dense that a single sugar cube of it would weigh as much as a mountain. Now imagine taking that entire, unimaginably dense object and spinning it up to hundreds of rotations per second, while simultaneously concentrating and twisting the magnetic field of its progenitor star into a knot of unimaginable intensity. That is a magnetar. Their magnetic fields are the strongest known in the universe, up to 1,000 trillion times more powerful than Earth's. If a magnetar were located halfway between Earth and the Moon, its magnetic field would strip the data from every credit card on the planet. But SGR 1935 plus 2154 did something that catapulted it from a fascinating oddity to a landmark discovery. In April 2020, this distant magnetar did not just twitch, it screamed. It emitted a colossal, millisecond-long burst of energy so bright it temporarily blinded X-ray telescopes. At the exact same moment, radio telescopes on Earth detected an incredibly powerful, fleeting flash of radio waves coming from the same precise point in the sky. This was the first time a fast radio burst, one of the most perplexing mysteries in modern astronomy, had ever been definitively linked to a known object within our own galaxy. Fast radio bursts, or FRBs, are intense bursts of radio waves that last mere thousandths of a second. Yet in that flash they can release more energy than our Sun emits in 80 years. For over a decade, their origin was a complete enigma, with theories ranging from merging neutron stars to, inevitably, alien technology. The simultaneous detection from this magnetar provided the smoking gun. It proved that at least some FRBs are generated by these immensely magnetic stellar corpses. The leading theory for how a magnetar creates such a burst is as violent as the star itself. The star's crust, a rigid lattice of iron nuclei, is under unimaginable strain from the twisting magnetic fields locked inside. This strain can build until the crust suddenly cracks, a starquake on a scale that makes our planetary tectonics seem trivial. This seismic event releases a cataclysm of energy, shaking the magnetic field lines anchored to the star's surface. Charged particles trapped along those lines are then accelerated to near light speed, producing a brilliant flash of X-rays and gamma rays. The convulsion also launches a blast wave of electrons and other particles out into the surrounding magnetic environment. As this shockwave plows through the magnetar's own debris field or the thin interstellar medium, it generates a coherent, lighthouse-like beam of radio waves, the fast radio burst we detect. SGR 1935 plus 2154 gave us the Rosetta Stone for understanding these cosmic shouts. It demonstrated that the engine for at least one class of these mysterious signals is the apocalyptic magnetism of a dead star cracking under its own internal stress. Yet the mystery is not fully solved. Many fast radio bursts from other galaxies are far more energetic than the one from our local magnetar, and some even repeat in unpredictable patterns. This suggests magnetars might be just one source among several, or that magnetars in different environments or stages of life can produce bursts of vastly different strength. This one object bridged two great cosmic puzzles, tying an ephemeral radio whisper from the distant universe to the tangible, ferocious physics of a stellar corpse in our own backyard, proving that sometimes the key to a deep cosmic mystery is not a new telescope, but a local explosion loud enough to finally get our attention. The magnetar's definitive crack links a cosmic shout to a tangible corpse, but sometimes the universe's past speaks to us in whispers reflected from cosmic mirrors. 340 years ago, a new star blazed into existence in the constellation Cassiopeia, a supernova so bright it was visible in the daytime sky for weeks before fading from view. All that remains today is Cassiopeia A, a tangled, expanding web of shock-heated gas and dust, the stellar debris still screaming outward at thousands of kilometers per second. For astronomers, this presented a frustrating historical gap. The light from the initial explosion reached Earth in the late 1600s, witnessed by observers who lacked the instruments to study its spectrum, its colors, its chemical fingerprint. The most scientifically precious moment was a historical footnote lost to time. That is, until we learn the universe keeps its own records. In the early 2000s, astronomers pointed the most powerful telescopes at the remnant and discovered something astonishing. Surrounding the chaotic core of Cassiopeia were faint, shimmering rings of light, expanding outward like ripples in a pond. These were not part of the remnant itself. They were light echoes. Here is how this cosmic replay works. When the star exploded, it unleashed a flash of light in every direction. Most of that light traveled directly toward Earth, arriving in 1680. But some of that initial flash traveled at a slight angle, shooting off into the darkness until it encountered vast, distant clouds of interstellar dust trillions of miles away. That light bounced off the dust like a flashlight beam hitting a wall and was reflected toward us. Because it took a longer, indirect path, this reflected light is only now arriving at Earth centuries later. We are not seeing the explosion itself, but its reflection, its ghost. This phenomenon is more than a pretty optical illusion. It is a time machine. By analyzing the spectrum of this echoed light with modern instruments like the Hubble and Spitzer space telescopes, astronomers have been able to perform an autopsy on a 340-year-old explosion in real time. They can dissect the chemical composition of the blast, measure its temperature, and understand the dynamics of the shockwave as it first erupted from the dying star. It is as if we found a pristine recording of a historic event everyone thought was lost, allowing us to study it with technology its original witnesses could never have dreamed of. The light echo from Cassiopeia grants us a second chance, a do-over for one of the galaxy's most famous stellar deaths. It proves that the cosmos has a long memory, and that sometimes to see the past clearly, you must wait for its reflection to finally catch up with you. Light echoes give us a second chance to witness the past, but some of the most compelling evidence in astronomy points to a present we have yet to see at all. Far beyond the orbit of Neptune, in the frigid, sunless expanse known as the scattered disk, a handful of small, icy worlds are behaving very strangely. Their elongated orbits are not just randomly oriented, they seem to be clustered, tilted in a similar direction, and aligned in a way that defies the gravitational influence of the known giant planets alone. This peculiar orbital architecture is the primary evidence for a tantalizing hypothesis: the existence of a massive, unseen world lurking in the outer darkness, a potential planet 9. The idea is not new, but it gained serious traction in 2016 when astronomers Konstantin Batygin and Mike Brown published a detailed analysis of these distant objects. They argued that the odds of this specific orbital clustering happening by pure chance were astronomically low, less than 0.0007%. Something, they proposed, must be shepherding them, its gravity sculpting their paths over billions of years. Based on the observed anomalies, this hypothetical planet would be a true giant with a mass roughly 5 to 10 times that of Earth. Its orbit would be monstrously large and elliptical, taking between 10,000 and 20,000 years to complete a single journey around the Sun. At its farthest point, it would be over 1,000 times more distant from the Sun than Earth is. This would place it in a realm of perpetual twilight, where the Sun is merely the brightest star in a black sky. The search for this phantom world is one of the great modern treasure hunts in astronomy. Teams are scouring archival data from sky surveys and using powerful telescopes like Subaru in Hawaii to meticulously scan the predicted swath of sky where it might be hiding. The challenge is immense. It would be incredibly faint, reflecting only the tiniest sliver of sunlight, and its motion against the background stars would be agonizingly slow. Finding it is like looking for a single, dim coal in a vast, dark field, and you are not entirely sure which field to look in. Yet, the Planet 9 hypothesis is not without its critics, and alternative explanations for the orbital clustering have been proposed. One possibility is that the gravitational pull of the collective mass of all the smaller objects in the Kuiper belt itself could, over immense timescales, produce a similar shepherding effect without needing a single large planet. Another, more radical idea suggests that the anomalies are not caused by a planet at all, but by the accumulated gravitational influence of a primordial black hole, a leftover from the Big Bang with the mass of a planet but compressed into a space smaller than a baseball. This would make it utterly invisible to optical telescopes, detectable only by its gravity or by the occasional flash of light as it ripped apart a passing comet. Whether it is a frozen super-Earth or an ancient black hole, the evidence from the outer solar system is a powerful reminder that our inventory of the cosmic neighborhood is likely incomplete. The hunt continues, a slow, patient scan of the infinite dark, driven by the conviction that the most familiar system of all, our own, may still hold a giant secret in its farthest, coldest reaches. The hunt for Planet 9 is a search for a giant hidden in our own backyard, but in 2017, astronomy witnessed the arrival of a confirmed visitor from a distant, unknown front yard. Tumbling through our solar system, the Pan-STARRS telescope in Hawaii spotted a faint point of light moving at blistering speed. It was given a name that captured its historic nature, Oumuamua, Hawaiian for scout or messenger from the distant past. This was not a member of our solar system. Its trajectory and extreme velocity made it unequivocally the first known interstellar object ever detected passing through. The initial data was baffling. It exhibited no visible coma, the fuzzy cloud of gas and dust that surrounds an active comet. This suggested it was a rocky asteroid, a simple interstellar rock. But its light curve, the pattern of its brightness over time, told a different story. The object's brightness varied by a factor of 10 as it rotated, an extreme fluctuation that meant only one thing: it had a highly elongated shape. The best fit was a cigar or pancake-like form, with an estimated length up to 10 times its width. Nothing in our solar system looks quite like that. Then came the second, more profound anomaly. As Oumuamua sped away from the Sun, its path deviated slightly from what was predicted by gravity alone. It was experiencing a tiny but measurable non-gravitational acceleration, a gentle push that made its outward journey a little bit faster. For comets, this is common, caused by the rocket-like effect of vaporizing ice or outgassing, which jets material into space. But Oumuamua showed no visible signs of outgassing, no dust tail, no coma. So what was pushing it? The scientific debate ignited and continues to this day, centered on two compelling possibilities. The first, and most widely accepted within the astronomy community, is that Oumuamua was a very peculiar comet after all, just one made of exotic materials. Perhaps it was composed of very pure, hard nitrogen ice, like a chunk of a Pluto-like world from another star system. As it neared the Sun, this nitrogen ice could have sublimated directly from solid to gas, producing a thin, invisible jet of nitrogen molecules that provided the thrust without releasing the dusty debris that creates a visible tail. Alternatively, its nucleus could have been so old and heavily processed by cosmic rays that it was essentially a crusty, carbon-rich mantle, and the outgassing happened through rare, localized jets that were too faint for our telescopes to see. The second possibility, far more speculative but impossible to fully dismiss, is that the acceleration was caused by radiation pressure from the Sun itself. For this to work, Oumuamua would need to be extremely thin and light, a millimeter-thin solar sail of natural origin. This idea fueled the most controversial hypothesis of all, that the object could be artificial, a piece of discarded technology from an alien civilization like a light sail fragment. While this captured the public imagination, the scientific consensus strongly favors a natural explanation, precisely because nature is so adept at creating strange and wonderful things we have yet to catalog. Oumuamua's true legacy is not a single answer but a paradigm shift. It proved that interstellar traffic is real, that pieces of other planetary systems are sailing through our own on a regular basis. It showed us that our solar system's inventory of comets and asteroids is just a local sample, and that the galaxy is likely full of bizarre, icy planetesimals shaped by alien suns and ejected into the deep freeze of interstellar space. It was a messenger, all right, and its message was humbling. The universe is not only weirder than we imagine, it is weirder than we have yet had the chance to imagine. Our galactic center is not a simple sphere of stars, it is shaped by a colossal, rigid backbone. Spanning thousands of light years, a dense bar of ancient stars cuts directly through the Milky Way's heart, a structure that fundamentally dictates the rhythm and flow of our entire galaxy. This galactic bar is not a solid object, but a vast, gravitationally bound aggregation of millions of stars, all moving together in a slow, synchronized orbit around the core. Imagine a swarm of bees so immense it forms the rough shape of a peanut or a football, with the entire swarm rotating as a single, ponderous unit. This rotation is the key to its influence. As this massive bar turns, its immense gravitational pull creates powerful waves and resonances throughout the galaxy's vast disk of gas and stars. It acts like a giant cosmic paddle, stirring the primordial soup of hydrogen gas that fills the spiral arms. This stirring is not gentle. It compresses the gas, triggering cascades of star formation along specific lanes. In many ways, the grand spiral arms we so admire are not permanent structures, but density waves, traffic jams of stars and gas, perpetuated and shaped by the gravitational tug of this rotating central bar. Its influence even extends to our own quiet corner of the galaxy. Our solar system, orbiting about 27,000 light-years from the center, does not travel in a simple, circular path. Our motion is subtly perturbed by the bar's gravitational field. We are not simply circling a point, we are orbiting within a dynamic, living structure whose central engine is this slowly churning rod of stars. This bar may also hold clues to the galaxy's violent history. Many astronomers believe such bars form naturally over time as a spiral galaxy matures, the result of gravitational instabilities that gradually funnel gas and stars inward, feeding the central supermassive black hole and shaping the galactic ecosystem. Its very existence tells us that the Milky Way is not a static portrait, but an evolving, dynamic entity, and at its core lies this immense architectural feature, quietly conducting the symphony of billions of stars. Deep within the galactic bar's gravitational sway, another invisible force sculpts the chaos. Surrounding the supermassive black hole Sagittarius, a star, astronomers have discovered a monster of a different kind, not of mass but of magnetism. These are not the tangled, weak fields found throughout most of the galaxy. Near the core, magnetic fields become organized into powerful, linear structures, like vast, invisible rivers of force threading through the darkness. Mapping something you cannot see directly requires ingenious methods. Scientists use the Stratospheric Observatory for infrared astronomy, a telescope mounted on a modified jetliner, to study polarized light from dust grains swirling near the black hole. Think of polarization like aligning tiny compass needles. The intense heat from surrounding stars warms microscopic dust particles, which then re-emit that energy as infrared light. As these dust grains spin, they naturally align themselves with any ambient magnetic field, much like iron filings around a bar magnet. The light they emit becomes polarized, its waves vibrating in a preferred direction parallel to the field lines. By meticulously measuring the polarization angle across the entire central region, astronomers could trace the direction and infer the strength of these hidden magnetic rivers. The resulting map was stunning. It revealed vast, ordered magnetic field lines stretching for light years, some pointing directly toward the supermassive black hole itself. This is where the monster's purpose becomes clear. These magnetic fields are not passive decorations, they are active participants in feeding the cosmic abyss. The space around Sagittarius, a star, is filled with hot, ionized gas, material that could potentially fall in and fuel the black hole's growth. But gas has angular momentum. It wants to swirl around in orbit, not fall straight in. Magnetic fields provide a cosmic transport system. The powerful, organized field lines act like guide rails or funnel walls, channeling this turbulent plasma inward. They can also extract energy from the spinning gas, allowing it to lose momentum and spiral closer to the point of no return. In essence, these magnetic monsters may be the primary architects of the black hole's dinner plate, the accretion disk shaping how and when material is delivered. Their discovery solves a long-standing puzzle. For a supermassive black hole to grow to its observed size, it must have consumed vast amounts of material over billions of years. These immense, structured magnetic fields provide the missing mechanism, a way to efficiently overcome the gas's natural tendency to orbit forever and instead steer it relentlessly toward the event horizon. They are the silent shepherds of the galactic core, their invisible lines conducting the final, fatal symphony of matter into the dark. The magnetic monsters channeling matter toward the black hole also possess the power to fling entire stars into the eternal void. These are the hypervelocity stars, celestial projectiles rocketing through the galaxy at speeds exceeding 1 million miles per hour, so fast they are destined for a one-way trip into intergalactic space. Their origin story is written in the violent geometry of the galactic core. Picture a binary star system, two suns orbiting each other, wandering too close to the supermassive black hole, Sagittarius A star. The black hole's immense gravity can tear this partnership apart in a brutal gravitational slingshot. Here is how the cosmic mechanics work. As the binary pair approaches, one star is captured into a tight orbit around the black hole. The other star, in a transfer of immense orbital energy, is violently ejected in the opposite direction. It is a perfect natural catapult. The captured star sacrifices itself to the black hole's grasp, while its partner is flung away at a staggering fraction of the speed of light. The energy for this stellar cannon shot comes directly from the black hole's gravitational well. We are not witnessing an explosion, but a flawless gravitational maneuver, a three-body interaction of breathtaking precision and power. The trajectory of these exiled stars is a permanent scar of that encounter. They do not curve along the gentle arcs of the Milky Way's rotation. They shoot outward on nearly straight, radial paths, punching through the galactic disk and into the halo, their speed so great that the collective gravity of hundreds of billions of stars cannot hold them back. They become galactic escape artists. Their eventual fate is a lonely exile. They will cross the diffuse boundary of the Milky Way's gravitational influence and sail forever into the cold, vast emptiness between galaxies. There, in that profound darkness, they will live out their lives as solitary beacons, their light no longer part of a spiral arm but a lonely signal in an ocean of nothing. For astronomers, these stars are more than just runaway curiosities. They are invaluable probes. By tracing their paths backward across the sky, scientists can map the gravitational field of the galactic center with incredible accuracy, confirming the mass and influence of the black hole that expelled them. Their composition tells a story, too. Many are hot, blue, and massive, suggesting they were born in the intense star-forming regions near the core, only to be violently evicted in their cosmic youth. Each hypervelocity star is a living tracer bullet fired from the galaxy's central cannon, carrying with it the immutable signature of the abyss that created it. They remind us that the heart of the Milky Way is not just a consumer of matter, but a powerful engine of exile, forever casting out pieces of itself into the endless night. The southern counterpart of this colossal structure is no mere mirror image, but a key to unlocking the eruption's true nature. While both Fermi bubbles stretch 25,000 light-years from the galactic plane, recent observations reveal subtle asymmetries in their shape and emissions. The southern bubble appears slightly more elongated and diffuse at its edges in certain wavelengths, a clue that the medium it expanded into was not uniform. This irregularity is a vital forensic detail. It suggests the bubbles did not inflate into a perfect vacuum, but plowed through a pre-existing, patchy halo of hot gas left over from earlier, quieter epochs of galactic activity. The bubbles are not the first event, but the most recent and violent chapter in a long history of outbursts from the Milky Way's core. Cutting-edge observations from telescopes like the Rosetta X-ray Observatory have added a stunning new layer to our understanding. They have mapped the bubbles in soft X-rays, revealing intricate, shell-like substructures within their vast volumes. These are not smooth balloons of gas, but bubbles within bubbles like the layered skins of a cosmic onion. This nested architecture strongly points toward a history of repeated, episodic energy injections. The supermassive black hole, Sagittarius A star, may not have had one single cataclysmic belch millions of years ago, but a series of powerful hiccups. Each outburst would have sent a new shockwave racing outward, piling into the material blown out by the previous one, creating these distinct internal shells. Alternatively, these ripples could be the echoes of a starburst period where waves of supernova exploded in succession, each wave adding its energy to the growing structure. The latest radio telescope data adds another critical piece, mapping the interaction between the bubble's hot gas and the galaxy's pervasive magnetic fields. The results show these fields are not just present, but are stretched and ordered along the bubble's surface, acting like a containing envelope that helps maintain its sharp, defined edges over millions of years. This magnetic sheath prevents the hot gas from simply dissipating into the galactic halo, explaining why we can still see these ancient structures today. The most compelling modern synthesis suggests a hybrid history. It begins with a period of intense star formation at the galactic center, a starburst that filled the region with massive, short-lived stars. Their combined stellar winds and eventual supernova created an initial pressure wave, clearing a path. This activity may have also funneled gas toward the central black hole, awakening it and triggering a powerful jet phase. The black hole's focused energy then rode the pre-cleared channel, inflating the bubbles to their immense observed size in a relatively short, violent burst. We are therefore looking at a fossil of combined fury, the accumulated signature of both stellar and black hole violence working in concert. The Fermi bubbles stand as a permanent testament to a time when our galaxy's heart was not quiet, but roared with an energy that shaped its entire halo. They are a reminder that the Milky Way has a lively and explosive personality, one whose most dramatic episodes are written in faint X-ray light across the sky, waiting millions of years for us to learn how to read them. From the magnetic monsters shaping our galaxy's core to the solitary diamond world forged in stellar death, this journey reveals a cosmos of breathtaking and relentless strangeness. Each of these 25 objects is a fundamental challenge, a cosmic puzzle piece that refuses to fit neatly into our existing maps of reality. They prove that the Milky Way is not a serene collection of familiar lights, but a dynamic, often violent, and always inventive arena. A star older than the universe itself, a galaxy made of almost pure shadow, a structure of perfect geometry born from chaos, these are not mere anomalies. They are signposts pointing toward the profound gaps in our understanding, the places where our physics must stretch or break to explain what we see. They remind us that every mystery solved inevitably reveals two more waiting in the dark. This incredible diversity, from the hypervelocity stars exiled forever to the old smokers patiently seeding the galaxy with dust, shows a universe in constant creative flux. So after this tour of the galaxy's greatest hits of weirdness, we turn the question to you. Which of these 25 strange objects captured your imagination the most? Was it the haunting silence from the wow signal region, the violent heartbeat of a magnetar, or the impossible geometry of the red rectangle? Or perhaps you know of another galactic enigma, a cosmic oddity that deserves a place on this list. Share your thoughts in the comments below. The universe is vast, its mysteries endless, and the next great discovery is always waiting just beyond the edge of our current light.